let's try the square root of 27. So the square root of 27 is irrational. It's not going to give us a nice whole number, but we can try and simplify it. So we ask ourselves, what two numbers multiply to give us 27? And we can do 9 times 3. And then since we have a product on the inside, we can break it up into a product of square roots. And the square root of 9 we can actually take. That's just 3. So the square root of 27 can be rewritten as 3 times the square root of 3. And let's try the square root of 150. And if you're not sure what the best two numbers are to use, just go with whatever's easiest. For instance, this ends in a 0, so it is a multiple of 10. So we can do 10 times 15. But 10 and 15 don't separate into nice, neat square roots. So let's just break these both down further. Let's say 10 is just 2 times 5, and 15 is 5 times 3. And then basically, with this product here, you want to pair up the numbers. Because if you can pair them up, then you can take a square root of that. Because for instance, we have 2 times 3 times 5 times 5, but that's just 25. And 25 you can actually take a square root of. So I will separate this. I'm just going to reform this into 6 because we're not going to be able to simplify that. So let's just say we have root 6 times 25, or breaking them up into a product of square roots, you can have root 6 times root 25. And then the square root of 25 we know is just 5. So you get 5 root 6. So one way to look at it is that every time you can pair numbers up underneath the square root, when you break it down into their essentially prime factorization, every time you can pair up numbers, you'll be able to pull one of those out. Okay, let's do a couple more examples with these. Let's say we have the square root of 80, and 80 is many different numbers paired together, but let's just do 8 times 10. So it's just 8 times 10, and neither of these gives us a nice, neat square root, so we're going to have to break them up further. Let's break 8 up into 4 times 2, and 10 into 2 times 5. Now looking at this, 4 we can split up, because we can take a square root of 4. And then we can pair the 2's together, because 2 times 2 is 4, and we can take that square root. But 5 isn't going to be able to pair with anything, so we're not going to be able to do anything to simplify 5. So let's just rewrite this as 4 times 2 times 2, which is 4, times 5. And now breaking it up into a product of square roots, we'll have root 4 times root 4 times root 5. And each of these is just equal to 2. So you get 2 times root 5, or simply we have 4 times the square root of 5. And that would be our final answer right there. And let's do one last one. We'll do a fairly hard one. Let's say we have the square root of 450. And with this one, since it ends in a 0, let's just do 10 times 45. And we can split it up from here. So 10 we know is just 5 times 2. So I'll write 2 times 5. And then 45 is 5 times 9. And then from here, the 9 you can take a square root of, and if we paired the 5's together, you can take a square root of that. So let me rewrite this as root 2 times 25 times 9, and then we can break it up into a product of square roots. So we have root 2 times root 25 times root 9. And so the square root of 2 we can't simplify, but the square root of 25 is 5. The square root of 9 is 3, so both of those essentially come on the outside of the square root. And, the last step is we're just multiplying by the square root of 2, since we couldn't simplify that. So 5 times 3 is 15. So 15 times by the square root of 2 is the simplification of the square root of 450. So it does look a little bit nicer. At this point, you're only dealing with the square root of 2, which is like the smallest irrational square root we have, with the whole numbers at least. So it will simplify things a fair amount. Now, I would not argue that this is the most important skill to learn in algebra, but it's definitely an important thing to learn. It is something that comes up repeatedly. They'll come up with imaginary numbers and, taking square roots of negative numbers. You'll need to know how to do this. It'll come up in the quadratic formula and being able to simplify the square root in that, which we call the discriminant. And it comes up in other applications as well.